In this video, I'm going to talk about graphing a system of inequalities. So basically what this means is when you have two inequalities and you want to find the area where both are true, or it could be more than two, but we're going to work with two. Um, so I'm just going to number these. I'm going to call this one number one. I'm going to call this one number two. The first thing is to just graph each one separately. So these first three rules are telling about graphing an inequality, just graphing one at a time. And then we're going to put that together to see where the two areas overlap. So I just numbered these as equation one and two just to make it easier to see what we're doing here. So for equation one, I'm going to graph this by finding the x and the y intercept. So if x is 0, what is y? If y is 0, what is x? Um, and I'm going to treat this as if it's an equation. So I'm just trying to find the line 2x plus y equals 6. So in this case, if x is 0, what it basically means is this whole term is just 0. So the y is going to equal 6. So that gives us the point 0, comma 6. And then another point on the line, if we're graphing 2x plus y equals 6, and we're saying that the y is 0, then 2x is equal to 6. That means x is going to have to be 3 if we divide both sides by 2. So that gives us the point 3 comma 0. So I'm going to go ahead and just focus on this first equation and kind of finish things up with this one. So I'm going to come down here. I'm going to give space for the second one too, but I'm going to draw a graph down here that we can use. And I need to be able to plot these 2 points. I need to plot 0, comma 6 and 3, comma 0. So 1, 2, 3, 4, 5, 6. I'm going to call that my 0, comma 6. And then over here, 1, 2, 3, comma 0. Because this is not, it doesn't have the or equal to, it's just a less than, I'm going to do this as a dotted line. And the other inequality is going to be the same. So I'm going to do a dotted line connecting these points. So something approximately like that. And then I need to see where I would shade. So I'm going to use this 0, 0 as my test point because it's not on the line. And that's a nice, usually pretty quick and easy to test zeros. So I'm going to put that into the inequality and see if 2x plus y is less than 6. So this is my test 0, 0 in equation number 1, or in inequality number 1, really. I'm just going to say in number 1. So if I do 2 times 0 plus 0, is that less than 6? And the answer is yes, because 0 is less than 6. So this is true. So that means that for this line, I need to shade this side that includes the 0, 0. And I'm just kind of doing it, I can't really do it lightly, but I'm doing it, not completely, because we also need to see where the other line ends up to see where those two areas of shading overlap. So that's the key thing when you're working with two at once. So equation 2, I'm going to make the same kind of little table here. I have my x and y. I'm going to find the points when x is 0, what is y, and when y is 0, what is x. And this is for the equation. So 2x minus y equals 9. If the x is 0, I've got negative y equals 9. So y is going to be negative 9. So that gives me 1 point. For the other one, 2x minus y equals 9. If the y is 0, it means 2x equals 9. So x is going to be 9 divided by 2, which is 4.5, 4.5, whichever way you want to think about that one. So now I can plot these 2 points. So I've got the 0, negative 9, and 4.5, comma 0. So I'm going to plot those on here. So I need to go down to negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, we'll say is approximately there. And then 4.5. So I've got 1, 2, 3. Here would be my 4. Here would be 5. So somewhere right in between there would be the 4.5. So now I can connect these again with a dotted line because once again we have we don't have the or equal to. So this one is also going to be a dotted line connecting these 2 points. And then I have to again figure out where to shade. So I'm gonna go ahead and test 0, 0 again because that's again clearly not on my line. So I'm gonna test 0, 0 in number 2. And equation 2 says 2x minus y is greater than 9. So if I do 2 times 0 minus 0, is that greater than 9? I'm just going to put question marks here. And the answer is no. 0 minus 0, which would be 0. 0 is not greater than 9. So this is false. So I'm going to shade the other side. I'm going to not shade 0, 0. So let me just come back up here. So I'm not going to shade the 0, 0 for this one. I'm going to go this way. And then what we're looking for our solution to this, to make both true, is where the shading overlapped. And that happens, I'm going to get a color here I can use. So it happens between these two, like from here down. So it's kind of looks like a triangle, except it keeps going forever. So that's the area where both are true, where you can see the shading overlap. So that's the area of the solution. One other thing that you'll sometimes be asked is, what is this point right here where the two lines intersect? So I'll just quickly do that. So if we have our one equation, and we're treating it as the line, so we're doing the equations again. So 2x plus y equals 6. And then we also have our other equation was 2x minus y equals 9. So when I do this, the y's would, so I can solve this system by getting the y's to cancel. So then I get 4x is equal to 15. So the x, where this is going to be true, is going to be at 15 over 4, which would be the same as 3.75. And that's looking pretty good. Like, I mean, my graph is not perfect, but it looks like this point is almost to the 4. And then I can see what the y has to be for that to be true. So I can just plug into either of these equations. I'm going to go with the first one. So if I do 2 times 3.75 plus y, that has to equal 6. So this is going to give me 7.5 plus y equals 6. So then y is going to be negative 1.5. So this point of intersection is going to be at when x is 3.75 and y is negative 1.5. And that would be true if we put it into either equation. So if we put it, if we use this equation instead, it's also going to be true. So that's it. So we have the region and we found the specific point where they intersect also. So that is it for that video. Thank you.